Good day, everyone. Today we are moving to Taylor series or expansion of solving limit, like how we can use Taylor series or expansion to solve limit. Okay, so these are the expansion we'll be using whenever we want to solve problem. These are the expansion. It can be more than this depending on what they give us, and that one will require us to prove out. So if you want me to do a video on Taylor series, you can comment in the comment section so that I can do it. Okay, so just make sure you know all this at its way what we are going to be using it whenever we are solving questions. Okay, so follow me as we dive into the what into this method. Okay, let's go. So our first question is this. So we are using Taylor series to solve. Don't forget to subscribe to the channel, like, comment, and share to your fellow friends. And make sure you go through all the part that have been posted earlier for further and more understanding of this topic. Okay, now let's go. Okay, now this is it. I want to use Taylor series to what? To solve this one. Okay, what am I going to do? I should know that the Taylor series, the expansion of sine x is what? Is sine x is equal to x minus x raised to power 3 over 3 factorial plus x raised to power 5 over 5 factorial minus, it goes on like that. Okay, so this is the expansion for what? For sine. You understand? So if you want me to do a video on how to know this expansion, how to prove them out, you can comment so that I can do it for you. So it means that I will substitute this in place of sin s here. So we have the limit as s tends to 0 of x minus x raised to power 3 over 3 factorial plus x raised to power 5 over 5 factorial minus, it goes on like that, minus this x, everything over what? X raised to power what? 3. Right? Now, here I can say this one cancel this one, because if I should open the bracket, it will cancel it. Do you understand what I'm saying? And what I have left, I have what? Minus x raised to power 3 over 3 factorial plus x raised to power 5 over 5 factorial minus, it goes on like that, everything over x raised to power 3. Right, you see that this is the lowest degree of x that we have, right? So I can factorize it out by saying the limit as s tends to 0 of x raised to power 3, right, open bracket, minus 1 over 3 factorial plus x squared over 5 factorial, it goes on like that, right, over x raised to power 3. So what am I going to do? What am I going to do? Like this one, we cancel this one, right? So we have the limit as s tends to 0 of minus 1 over 3 factorial plus x squared over 5 factorial, and it goes on. Now, you should note that now as s tends to 0, if I should distribute the limit across everything, it goes on like it is continuous. If I should distribute the limit, everything from like starting from x squared would be what? 0 over their factorial. So which means that everything along the line will turn to what? 0, and it will remain what? Minus 1 over 3 factorial. So the limit as s tends to 0 of this is equal to minus 1 over 3 factorial, which is minus 1 over 3 times 2 times 1, which is what? Minus 1 over 6. So you just have to know the expansion of the trick that they give you, or any exponential or logarithm. Like, you just have to know the expansion, and if you want me to explain how it is expanded, you can comment it the comment section so that I can do it for you. Okay, now let's move on to another question entirely. Here we have another question that we have to lay our hands on. Now this one is it. Now we are using Taylor series, right? So it means I need Taylor series expansion for this e raised to power x, and according to what I show you earlier, e raised to power x is equal to what? 1 plus x squared over 2 factorial plus x raised to power 3 over 3 factorial, and goes on like that, plus it goes on like that. Okay, now I will just substitute all this in place of e raised to power x. So I have the limit as s tends to 0 of 1 plus x squared over 2 factorial plus x raised to power 3 over 3 factorial plus it goes on minus 1 minus x squared over 2 everything over x raised to power 3. This one is also straightforward because you can see that this one will cancel this one will also cancel this, and this one will also cancel. So I have x raised to power 3 of, if it is continuous, you know, here we have x raised to power 4 over 4 factorial, right? So I have x raised to power 3 over 3 factorial plus x raised to power 4 over 4 factorial, and goes on like that, everything over x raised to power 3. Now I can still do something because this one is the lowest degree of s that we have, so I can factorize it out. That is x raised to power 3 into 1 over 3 factorial plus x over 4 factorial, everything over x raised to power what? 3. Do you understand? Now this one can what? Cancel this one. So what I have left is this, right? Plus it goes on, right? Now this is what we have left. So now as s tends to 0, this one is a constant, it will stay. But from this one up to the what? Up to where it stopped, it will what? All of them will be 0 because each of them will have x at the top. You understand? That is 0. The next one will be 0 over 5 factorial, 0 over 6 factorial, and the all tends to 0. So it means that it is only this one that stays, which is what? 1 over 6. Do you understand? So you just have to know the expansion of the trig, logarithm, now exponential, whatever they give you in the question, and just substitute them with their expansion. Then look for things that cancel out, and then continue and simplify, get your answer. That's how it is. Okay, now let's move on to another one. So this one is another one on its own. Now let's lay our hands on it. Okay, the expansion for this line 1 plus x. Okay, so let's take a look at this one too. The Taylor series expansion of this one is what? So you just replace it, is equal to x minus x squared over 2 factorial plus x raised to power 3 over 3 factorial minus, and it goes on like that, right? So according to what I showed you at the beginning of the video, so we have the limit as s tends to 0 of, replace this one with this expansion, which is x minus x squared over 2 factorial plus x raised to power 3 over 3 factorial minus, it goes on like that, minus x, everything over x squared. Okay, now I can say this one will cancel this one because if I should open the bracket, that's what will happen. So it will remain the limit as s tends to 0 of minus x squared over 2 factorial plus x raised to power 3 over 3 factorial minus, it goes on, everything over what? X squared, right? Now I can say I can factorize x squared out because it's the lowest degree of s that we have. So I can say the limit as s tends to 0 of x squared, right, open bracket 1 minus 1 over 2 factorial plus x over 3 factorial, and it goes on like that, don't forget, over x squared. So this one can cancel out. So we have the limit as s tends to 0 of minus 1 over 2 factorial plus x over 3 factorial plus the what? The remaining one. No, minus is supposed to be negative, minus the remaining. So now if I should substitute 0, this one will be 0 over 3 factorial. The next one also we have to remain x, that is, that one should be x squared. Okay, yes, it should be x squared. So x squared over 4 factorial, that will be 0 squared over, and that one will also what? Lead to 0. So the only constant that we have left is what? Minus 1 over 2 factorial, and our answer is what? Minus 1 over 2. So that's the answer for this one. Just know how to represent it with what? Taylor series expansion of what I showed you earlier. Substitute it, like replace it with what is in the initial question, and then simplify. You should be able to get that. Now let's continue with what we are doing. Let's move on to another part. So we have another one, that is x over e raised to power 2x minus 1. So this one will also require us to prove something out. That is e raised to power 2x, because I did not show you at the beginning of this video, it's not there. But if you want me to do a video, I already said earlier, comment it in the comment section and I will do it. So let's start this one. So e raised to power 2x expansion is 1 plus 2x plus 2x squared plus 4 over 3x squared s cube, and it goes on like that. Do you understand? It goes on like that. So you have to replace it here. So we have that the limit as x tends to 0 of x over 1 plus 2x plus 2x squared plus 4 over 3x raised to power 3, and it goes on like that. You get what I'm saying? Minus 1. So you should know that this one we cancel this one. So we have the limit as x tends to 0 of x over 2x plus 2x squared plus 4 over 3x cubed plus it goes on like that. So now I think I can factorize x at the what denominator, which is x open bracket 2, right, plus 2x plus 4 over 3x squared, and it goes on like that, right? So from here now x should be able to cancel x, so we have 1 over this, right? So this is what we have left. So if we now start to substitute 0, all these start from here, we cancel out. So our answer will only remain 1 over 2 because everything here will turn towards 0. So that's that for that one too. Now this is another question. So now I can say that ln cos x. So it means I have to find the expansion of this one, that is ln cos x. So for cos now, it is equal to what? For the expansion of cos, we have 1 minus x squared over 2 factorial plus x raised to power 4 over 4 factorial, and it goes on like that, right? So now this is the expansion, so I have to input it into this one. So ln of what? Cos now is now being ln of 1 minus x squared over 2 factorial plus x raised to power 4 over 4 factorial plus, so this is it. So I can just represent all this with what? Let's say plus 0 into, because the next one should be x raised to power 6, because they become smaller as we go down the what? Down the expansion. So now I can just say because we have the expansion for ln of 1 plus x, okay? I will just say let minus x squared over 2 factorial plus x raised to power 4 over 4 factorial be u. So I can just say ln, right? Ln of what? So we have 1 plus, because this is u, everything plus u, and the expansion of this will give us u minus u squared over 2 factorial. It's just that I'm not using x again, still the same expansion, plus it goes on 2. So I can just represent that one with 0 x raised to power 3, because x raised to power 3 is the length, because as we go down it becomes smaller. Now we have the expansion, so let me first find the u square. Since my u is this, so u is equal to, the square will be minus all over 2 plus x raised to power 4 over 24 all squared. Do you understand? Let me just make this one, make the expansion of this one, like just square this one, because if okay, let me just do it like this: x squared over 2 all squared plus 2 into minus x squared over 2 x raised to power 4 over 24 plus x raised to power 4 over 24 raised to power 2. Okay, that's the expansion. But let me just be, because it goes smaller as we go down, so this one is what I need. Let's say x raised to power what? 4, right? Minus x raised to power 4 over 4, x raised to power 4 over 4 all squared, right? Okay, now plus, let me just represent this one with, let's say, y, everything. You understand? So now we have this, we have our u squared. We can just substitute by saying it is equal to, our u is what? Minus x squared over 2 plus x raised to power 4 over 24, and this is it. So this is our u, right? U, okay, I'm substituting here, right? Okay, minus u squared over 2 factorial. This is our u squared. 2 factorial is 2. This is our u squared. We don't need y again, so we have minus x raised to power 4 over 8. So if you simplify this one, you have minus x squared over 2, right, minus 2x raised to power 4 over 24, which is equal to minus x squared over 2 minus x raised to power 4 over 12, right? So this is how it is. That is the length of this. I've substituted the u. Okay, the length of this, which is the length of cos everything, length of cos is x minus x squared over 2 minus, so you just substitute into this place because we have find the length of cos to be this. Do you understand? So it will now be, so we now have the limit as x tends to 0 of this, the length of cos minus x squared over 2 minus x raised to power 4 over 12. So we have plus x squared over 2 everything over x raised to power what, 4. So this one can cancel this one. What we have left, we have that the limit as x tends to 0 of minus x raised to power 4 over 12 divided by x raised to power 4. So this one we cancel this one. So we have the answer to be what, minus 1 over 12. So that's the answer. Just make sure that you know how to expand, how to express this one in an expansion in Taylor series. First find the expansion of this, put it inside bracket because it's the continuous thing represented by something, then use directly. Thanks for watching. Have a nice day. That's all I have for you today.